So continuing on with our last video, I hear you saying to yourself, well, self, this actually isn't too bad. But wait, it gets better. What about these ones? Remember we had talked about this. We had said if we had the arc cosine or the cosine of an angle, right, what should happen? Well, remember that what we want to get is we want to get an angle whose value is between 0 and pi. Now we can just step backwards right here and just remember it this way. If we're taking the arc cosine of something, right, we're going to take the cosine of pi over 4 and figure out what that should be. Well, working from the inside out, we know that's radical 2 over 2. And the arc cosine of radical 2 over 2 is an angle between 0 and pi, whose cosine would be radical 2 over 2. And that angle happens to be pi over 4. So in this case, right, this is an example of the situation in which if we were to take the arc cosine of the cosine of some angle x, right, we would just get x, right? The two would undo each other if and only if, though, if and only if x is an angle on the interval from 0 to pi. So what happens if we get outside of that? Let's try this next one right here. This is kind of weird. We've got the arc sine of the sine of 4 pi over 3. What we had said before here about the arc sine was that, well, if we were to take the arc sine of the sine of an angle of x, we would get x if and only if x was between negative pi over 2 and positive pi over 2. Well, that doesn't seem to be the situation right here, right? Now we've got 4 pi over 3. So let's figure out what we should do. In this case, just work our way from the inside out. Sine of 4 pi over 3. 4 pi over 3, that's a quadrant 3 angle, right? Quadrant 3 angle. And in quadrant 3, sine is negative. Right? So that means that we're going to be taking the arc sine and our reference angle right here is pi over 3, and we know that the sine of pi over 3, that's radical 3 over 2. So what will we say? Well, we're taking the arc sine. We're going to take the arc sine of the sine of 4 pi over 3, and that is negative root 3 over 2. Now, we need an angle between negative pi over 2 and positive pi over 2 that fits this bill. So in this case, we're going to say, well, that would have to be negative pi over 3 in the fourth quadrant, right? So negative pi over 3. So the answer right here is that it's not going to be a direct undo one with the other, right? In this particular kind of case, you have to be very careful that when you take the arc sine of whatever value you get, that value is between negative pi over 2 and positive pi over 2. So a similar thing could be said for our arctangent of the tangent of 3 pi over 4. What can we say there? Well, it's not going to be 3 pi over 4, right? That's because when we take the arctangent, right, the rule would be that the arctangent of the tangent of x is equal to x if and only if the value of x is between negative pi over 2 and positive pi over 2, but not including either of those endpoints, right? So if we keep that in mind, we can say, all right, this is the situation where we have to evaluate what's in the inside of that function directly. So arctangent let's see, tangent of 3 pi over 4. 3 pi over 4, well, that's found in quadrant 2. And in quadrant 2, we know that the tangent of any angle is negative, and that our reference angle is pi over 4, whose tangent is equal to 1. So we're taking the arctangent of negative 1. And we would say that this has to be an angle between negative pi over 2 and positive pi over 2. And therefore that arctangent of negative 1 has to be negative pi over 4, because it's the only angle on the interval from negative pi over 2 to positive pi over 2 whose tangent is equal to negative 1.